So here we have graphs of absolute value functions, and we want to see what the absolute value does to the graph. And basically, we really should understand what an absolute value does. We have our input, which could be a positive x, okay, and that can input into our absolute value function. And the output for that is going to be a positive x. Okay, so this is what our function looks like. However, we could also input a negative x into this function, and that output can also be positive. So what does that do to the function? Okay, so first of all, let's draw the original function, x minus 5. So we have a y-intercept at negative 5 and a slope of 1. So we end up with a graph that looks like this. Okay, and these are our x and y coordinates of that graph. Okay, so we just plug in an x and we get our y values. So the absolute value that is the boundary of when the plus becomes plus and the minus becomes plus, the boundary between plus and minus is 0. So what we really need to know is, when is this graph equal to 0? Okay, so what is the 0 of this function? So the 0 of this function happens to be at positive 5. So x equals 5. So what's going to happen then is, on the left side of this, I'll do this in a different color. So all this is less than 0. Okay, so when we plug this in, our output, when we do the absolute value on all those negative coordinates, what's going to happen is it's going to flip over and we're going to end up with positive 7. So negative 2 absolute value, or negative 2 minus 5 is negative 7. Absolute value becomes positive 7. 0 becomes positive 5. 2 minus 5 is negative 3. Absolute value becomes positive 3. 4 minus 5 is negative 1. Absolute value becomes positive 1. And the coordinate we really need in here is our 0 coordinate. So when x is 5, y is 0. And that coordinate is the point that is going to be our mirror point, because that's the point that doesn't change. And that's the boundary between our positive and negative. So when the absolute value actually does something versus when the absolute value stays the same. So from 5, when I draw my new coordinate here, my new graph, at that point, that's a key point. Because when the inside of the graph, inside the absolute value is equal to 0, that's the boundary. And on this side, everything just stays the same. Okay, so we end up with this linear function. It's the same as the original linear function. However, on the other side of that, we're going to have the coordinates that are going to be reflected in the other direction. Okay, so there's our coordinates. So negative 5, 0 is going to be at 5. Okay, 2 is 7. And the graph is just going to be a reflection. So this green graph is a reflection of the yellow graph there. And we end up reflecting this portion of the graph and basically folding it above the x-axis. So this is what the absolute value does. And so we can describe absolute value as a piecewise function in this way. So there's two parts to this piecewise function. Okay, so I'm going to write my f of x. And the two parts of this piecewise function are going to be represented by when the graph is positive. Okay, you don't need to put the positive in there, but I just want to make sure that we can see where the graph is positive. The graph is going to be positive in a certain domain. And when the graph is positive, nothing changes. There's no difference between the absolute value and the f of x. So it's just going to behave like a linear function with slope 1 and y-intercept of -5, but we have to make sure we know the domain. And the domain of that is going to be when x is equal to 5 and bigger. Okay, so that's the domain of when it behaves like the regular original linear function. Then there's a negative domain, okay, when it's negative. When the graph is negative, okay, we need to use the opposite, or negative x plus 5. Okay, so for those values when it's negative, we're going to just take this x minus 5 and multiply by -1, and that's going to flip it across that line and give us the green graph here. And that domain is going to be when x is less than 5. Okay, so this is what my graph's going to look like. So it's going to have a positive domain, which is a black part of that graph. It's going to have a negative domain, which is a part that got flipped. And we show that by that negative x plus 5. Now we could also do it like this. We could see that we're just flipping the original x minus 5 equation as well. So that's another way we can show it.